This video is for the question that I passed out in class yesterday to help you with your test prep about the home game attendance for Major League Baseball. And the question says the total home game attendance for Major League Baseball is the sum of all attendees for all stadiums during the entire season. The home attendance in millions for a number of years is shown in the table below. And it says for Part A to make a scatter plot showing the trend in home attendance and describe what you see. I've input this data into List 1 and List 2. Now when we go to Graph, Zoom Stat, here's what we see. So the description is there's a moderately strong linear association bordering on quite strong, especially without this outlier down here. We're able to get rid of this. We have a very strong linear association moving in the positive direction. As far as that outlier, it does need to be mentioned. If you can justify getting rid of that data value, you probably should, and then finish the question without it. I wouldn't expect you to know this, but in 1981 there was a baseball strike. Given that was a strike-shortened year, there were fewer games played, so home attendance was down. If we were going to use this in a prediction model, we're not going to assume there's going to be a strike, so we could definitely justify getting rid of it. So I will. Don't have to, and I'm not going to expect you to know that. But again, the description, we have a positive linear association, all right, with the presence of one outlier. It does end up having quite a bit of influence. If you want to run a linear regression with and without, you'll see that. I'm going to do it without. So what I've done for Part B, when it says to determine the correlation, I actually came into Stat Edit, and in List 3 and List 4, I copied List 1 and List 2, but if you notice, I got rid of 1981. So I'm going to run it without. So I go to Stat and Calc, and I run this linear regression. Remember, by default, it's going to use List 1 and List 2. For X and Y, respectively. I want to use List 3 and List 4. Okay, when I do that, I have a correlation of 0.99, and it says to comment on its significance. Well, it's a very strong correlation, and it is meaningful here. It's applicable because the original scatter plot is straight enough. It's quantitative data, and again, even with the outlier, it still satisfies the outlier condition. There's not a tremendous amount, but we would need to mention that outlier, okay, is reducing, okay, the correlation, okay, causing or possibly hiding a stronger linear association throughout the rest of the data. But without it, okay, again, definitely straight enough, definitely quantitative data, satisfies the outlier condition, okay, very strong here. Now it says to find the equation of the line of regression, comment on its significance. Well, in this case, we know, looking here at our order, this is the y-intercept of negative 52.6 approximately, and the slope is approximately 1.2. Okay, so the fact that we are predicting home attendance, so it would be attendance hat equals negative 52.6 plus 1.2 times the year. And that would be our regression equation. Now, to comment on its significance, what we need to do is we need to graph the residuals and just make sure it's appropriate, and then we can comment on this R squared value. In order to graph the residuals, we're going to graph those against X. The residuals have been calculated here in this regression. So what we're going to do, we're going to go to Stat, Edit, List 5, Second Stat, which is List. Make those the residuals, enter. We've calculated our residuals. So now when we go to Second Stat Plot, instead of doing List 1 and List 2, we are going to do List 1, okay, against List 5. Oh, dimension mismatch. I didn't mean to do List 1. I apologize. It should have been List 3. So we're going to get out of here. I'm going to go back there again. I apologize. Stat Plot. And I'm going to make this X list, List 3. Remember, we got rid of one of those values, so when we ran the residuals, it had one fewer than we had in List 1. So it should be List 3. And now when we graph Zoom 9, what we see is a pretty equal horizontal spread. Doesn't look like we have anything interesting left behind here, so we would say that, okay, the linear model is appropriate. And again, if you take a look at its R squared value, which is its measure of strength, or the percentage of variation in Y accounted for by the model or accounted for by X, what we see, again we were using list 3 and list 4, an R squared of 97% approximately. So 97% of the variation in home attendance is accounted for by the variation in the year, or accounted for by the model. So this is a very strong model given that it's appropriate. Interpreting the slope and the y-intercept, again, sorry, the slope is 1.2 approximately. So as the year increases by 1, the slope is going to increase by approximately 1. The attendance is going to increase by approximately 1.2 million people. And then the y-intercept, they would say at year 0, Major League Baseball drew a whopping negative 52.6 million people. Again, that doesn't mean anything, again, because baseball was not around in year 0. Okay? For Part E, it says to use our model to predict home attendance. We've talked about that model. Now, since we used 78 to represent 1978, when we plug in here, we want to make sure we plug in 98 instead of 1998. How much confidence do we have? Very little, because it is an extrapolation. And for the calculation of the residual, I will do in a second. You just heard the bell ring, which threw me off a little bit, but I don't want to be interrupted, so I'm going to stop the video here, and I'll come back and I will show you the calculation for the residual and show you how to match that up with what we have in our calculator.